You probably didn't hit the last blue button. I do that all the time.
Probably not.
There you go. Perfect.
All right. Very well. There we go. So can everybody hear me okay? Sound check?
You sound great.
Okay. I'll introduce myself, but before I do that, I'm going to make a little bit of an apology. I'm getting over a cold, so I may go off camera and mute the mic a second if I have to sneeze. So I apologize in advance. Thank you, Thelma. For those of you who I have not spoken with before, Rich Antonow, as she stated, as Thelma stated. I work for Microsoft. My role in Microsoft is called a security and identity technical specialist. What that means is I'm part of the account team where I cover all of our threat and analytics and our security tool sets. My background, my degree is in computer sciences. So yes, I know how to code. That is not what I do for a living. I'm the security guy. And when I do these briefings, I try to bring in the overall security into the discussion with the members that are either going to end up being coders, or after hearing some of this, you might even decide that maybe your future path is along the cybersecurity side, because there's certainly a big need for all that as well. Point of order, Thelma, if people have a question, are they able to post it and you can bring it up? Because I don't see questions.
I have the chats up. And okay. So, do you want me to interrupt you when their question shows up?
That would be great. And likewise, if I ask, I have one or two questions within here. Are they able to unmute?
Yes.
Okay. All right.
So the two ways you can ask the question, and you can say, "Excuse me, Rich, I have a question." You can put it in chat, and I'll go, "Excuse me, Rich, there's a question." So whichever way you're more comfortable doing it, feel free to do it that way, and we'll get your question answered. If he asks a question, please participate and answer.
Yeah.
If you're shy and you want to answer in chat, I'll let you have that. I'll read it for you. But either way, please answer. Thank you.
And I appreciate that. It's always a better experience for everybody. Over my years, in college and likewise, so many times I found that when somebody has a question, they choose not to speak up, and then later on you talk with your peers and you find out, oh, I wanted to know that same thing. So sometimes when you speak up, there's others that might want to know the same thing. I'm not shy whatsoever, and I don't take any offense to being interrupted, because this is your time. I might be presenting it, but it's your time. Okay. While I was talking, I do have the agenda on the screen, so you have a decent idea of what I'm going to cover. So again, the idea is I am going to talk about secure coding, but I got thinking about it this year, given all the bad things that are going on out in the world as far as threats and activities. I like to put a spin on it, or a flair on it, of you should know what's going on out there, so that as you're creating and writing your code, you can keep security of that code and the way it's processed, the way it's accessing data, top of mind. So let's get on the same page. Let's start with some definitions, right? Code, everybody should know that. Now, programming instructions used to develop an application. We got this. Debug. Verb, the process of identifying and taking bugs out. So therefore, programming is the process of putting them in. Yes, I hate to tell you this, if you're not aware, you're the one putting the bugs in. That's important because no matter how well you code, there will be bugs in there. So understand that coding by itself, by the sheer process, it's a process of iteration, right? So that's expected. Programmer. I think you all can understand that one. Okay, what's a threat? So throughout the day when I'm talking about threat and threat analytics, threat in this case means an actual action that is being done by some type of a threat actor. So, you'll hear me call them, and you'll hear that term quite a bit in the security world, a bad actor, right? So basically that's the bad guys that are doing the phishing attacks, and the nation state actors and so on, right? So those are terms that we're going to use throughout this. Having said that, I'm bringing you some statistics on this screen and the next screen, right? So I'm here to tell you, will not talk about any specific customers, but everybody I do work for as part of Microsoft, I do what's called state and local government. So all of my customers are either at the state level, like the state of Hawaii, the city level, city of Honolulu, utilities, any of those things, right? So there are a lot of things every day going on behind the scenes that you never hear about, right? So much of what we do in the world is confidence, right? And if every time there's some type of a breach or a cyber attack, people kind of lose confidence in, oh, is my data secure and so on, right? So I thought you'd be find it interesting in what is attacked most. So when you're looking at where you might ultimately end up working, just get a good understanding that all of these are the primary ones being attacked. Does anybody want to speak up and say why you think, these 5 are the most prevalent for being attacked?
Money.
I don't disagree. Could you expand just a little bit?
No.
Okay. No, that's fair. That's totally fair. Anybody else?
Is it because they have a lot of information about like personal stuff?
Absolutely true. That is a factor in there for sure. Usually, and it's both of what both of you just said. You're both absolutely correct. These are primarily attacked because of the sheer volume, the size that they are, finance, healthcare, and so on. As you just stated, when you're looking at finance, healthcare, government, right? You've got all these users that can be attacked and so on. But it's also because these organizations disparately do not have as much funding put into things like cybersecurity and so on that one would expect. Okay. I'm proud to say that Microsoft itself, we invest every year, we invest $5 billion specifically on security. In 2023, everybody's hearing about AI and so on, and I'll get into that towards the tail end of this discussion. We will talk about AI. Microsoft very much believes in it. As a coder, or if you do decide to get into the cybersecurity side, it will become very, very relevant to you. And quite frankly, as an individual, anybody who's looked at their emails on their phone, it's already very relevant to you, right? So in 2023, Microsoft invested $13 billion in the technology called OpenAI, and from that we developed our particular generative AI tools that are called Copilot. So we have a Copilot for security, a Copilot for Microsoft 365, a Copilot for Edge, and so on. So when I said that I was bringing this with kind of a flair of what you need to understand, take a look at the particular types of attacks out there. These become more and more prevalent because we're a connected world, right? Why do we see more and more happening? Why do we see these threats happening more and more now? Well, one of them is because we've become much more of a connected world, and everything is being having to support, say, remote workers, supporting services that are in the cloud. No longer can you be one of those organizations that you put your servers in a little room down the hall and you lock the doors and you don't have any connections to the outside world, and everybody wants to come in has to come in through a VPN and go directly to that. That worked for a while. Even then, of course, it wasn't completely secure, but it was a little bit more secure. Well, now we look at having to provide, and you have to think about this when you're developing code, right? Providing the ability for users to be able to do things like access whatever application you have. People want convenience, right? So they want an app that you can get from your phone, your laptop. You want to be able to work from various different places. So these are going to be a much more prevalent. Take a look at the particular different types of attacks. If you've never heard of any of these, I strongly recommend that you do a little bit of research. I'm not going to cover each one of them here. I'm certainly open to talking about any. But I do think these are the most popular types of attacks that would affect any organization. that would affect. It doesn't matter what type of code, whether you're creating games, you're doing an app specifically for a phone, whether you're doing an internal app, all of these become important. Okay, there's a lot of great sources out there. So the other great part about all this interconnectivity, the world is your oyster. You can get all sorts of data out there, so you can easily look at these. I highly recommend take a screenshot of these. I will provide these slides, by the way, at the end of this or after this closes, so you'll have these available to you as well. So I did say that even though this is about coding, cybersecurity and being a part of the security team is something that even if you start out as a coder, we have many individuals in my organization, Microsoft, that very much enjoy the coding side. Others have, maybe either started or said after doing that a while, say, hey, this cyber stuff's kind of exciting. I'm here to tell you, it's not going anywhere. There's a ton of jobs open. If you look at the yellow in the middle there, right now, today, actually, this is based off of numbers of 2023. There are 4 million jobs open, cyber jobs open already. So, and as Thelma was saying, yeah, we do tend to follow our paychecks, and cyber pays pretty well, right? So, what are the things you need to know? Well, if you're reading the bullets there, your very first one, I guarantee you've heard of a couple of them. But did you have any idea that organization-wise, this is not down to individuals. I'm not talking phishing, those goofy emails you get from the Nigerian prince, but actual cyber attacks to organizations of size. 2,500 or so. Pardon me. And realize these are just the ones reported to us. If you're an organization that you experience a cyber event and maybe you get it stopped right away and you want to stay, keep it on the down low and not be on the radar screen, there's tons more that just never get reported, right? The next part is, of those, 72% increase in data breaches, right? So of those cyber attacks, 72% get some type of data breach. I assume all of you, with all the zillions of emails we're getting and all the news going on, you probably heard various different things here within the last couple of days. Yesterday, once again, yesterday it was announced that 5 of the major carriers, think Verizon, AT&T, Cellular Mobile, all the major carriers, by name, I normally don't call it by name, but it was called in the articles. China specifically had hacked into those and were looking for specific email addresses for some of the candidates and the candidate staff going on today, right? So data breach is a huge thing. What would they be going after? Use your imagination, right? And anything you could think of, probably true, right? Look at the data breach, right? If they are successful in a data breach, it's a big business. 4.8 million. I will throw this out that in general, when we're talking about bad actors, bad guys, the vast majority, excluding the nation state, by the way, means something like the China's, the North Koreas, the Russias, where you've got an entire nation that has a cyber army that all they do is try to penetrate and cause havoc and steal state secrets, right? Outside of that, the vast majority of bad actors and hackers, they're going after money, right? Of some form or another, right? Either doing a ransomware attack, trying to steal data and sell it back to you, or resell that data somewhere else, or even just getting identities and selling those. Right? It's all about money. Okay, and then down at the bottom, again, I'm sure you're reading it here. The most targeted companies for phishing scams are Microsoft, Apple, LinkedIn, Google, Facebook. By the way, Microsoft owns LinkedIn, so we're 2 of the 5. We get attacked every day. So I also tell anybody, hey, Microsoft, I read, you had this kind of exposure or this. It's like, first of all, it's an order of magnitude. I mean, we've got billions of points across the U.S. So, to try to protect everything 100% perfectly is extremely difficult. You'll hear many times that I'll talk about if you're working the cybersecurity, you know, the defense side, you're trying to protect your organization. You've got to be right 100% of the time. The bad actor only has to be right once to get in. Any questions before I continue? Okay. So just quickly, pardon me. I knew that was going to happen. So just so you get an awareness, and again, yes, this is not about writing code. This is about understanding an environment and how a typical a threat actor or how a scenario happens. So when you're putting together a secure code, it's not, did I write this little piece of code properly? It's how is everything in the bigger picture all interconnected, right? So understand that when you talk about cyber breaches, if you're looking at an individual, if you get a phishing attack, meaning they sent an email to your phone and they want you to click on this link. Oh, you know, what's a typical one? Oh, Wells Fargo says that you've got this, we locked out your account because we saw some activity that looks nefarious. Click on this link to go check your account, right? Never do that. Go right to your Wells Fargo account directly, by the URL, go to there. Don't click on the links, right? A phishing attempt. What are they going after? They're actually going after your identity, right? Because they want to be able to steal your identity, do things like open credit cards in your behalf, maybe get to your bank account and be able to log in and take the money that you have. They want to be able to do home theft, all those other things, right? But as it relates to a company, an organization, when a phishing attempt is initiated, what is the bad actor going after? They're going after the company's data and intellectual property. Data itself can't respond to a phishing email. So they have to be able to target, pardon me, they have to be able to target users, get users to click on something, load a malicious payload, and then activity happens ultimately so that they can try to gain additional credentials and be able to get to data. And what they do with that data then is, you know, everything from ransomware to intellectual property theft. You know, think of stealing the data about, you know, the latest project that you're working on, maybe your code, right? So typically it's going to start with some entry point. Just so you know, humans are the weak link in this. AI, all the security tools in the world are not going to protect you from that one person that goes, oh, I think this is real. I wanted a Nigerian prince to give me $3.5289 billion. I'm going to click on that link. We're the short pole in the tent. So typically phishing is one of the major entries, right? When that happens, then what typically would happen is by clicking on that link, a malicious payload gets installed onto a workstation. And then depending upon who clicked that link, your credentials have certain levels of access. Your average Joe user probably doesn't have access to things like servers and so on. Maybe you do. You probably have access, maybe you're a member of a couple project teams, and you might have extra access to certain folders and so on in that data. If you're a programmer and you get compromised, where's all your code? Chances are, wherever it's being stored, you have access, right? Maybe you don't have access to your peers' code, but you have access to yours. Maybe you do have access to your peers' code, right? So lateral movement then means that they're going to compromise a workstation, then from there, reach out and try to get onto other workstations that maybe have loose credentials or be able to do things like a pass the hash and so on. Ultimately, they're trying to get what's called privileged escalation. Maybe your identity doesn't have domain admin rights, or maybe you don't have server admin rights. But if I was a bad actor and I got into your emails, what am I looking for? I'm looking for who you communicate with. So like, excellent. So maybe there's an email in there. It's like, oh wait, look, I see here where where they're talking to this individual, Jane Doe, and Jane Doe is a member of the help desk. Ooh. Help desk has added permissions. I'm now going to try to go up to her. So maybe I craft a malicious email to Jane Doe and say, hey, I'm having trouble with this here, with this link. Can you tell me if it's broken or something? And they point it to some place that's nefarious, right? So they're trying to do escalation. Eventually, these bad actors are very, very good at what they do. And also remember, they have pretty much unlimited time. So you need tools, you need automation to be able to identify these, determine whether they are false positives, true positives, and be able to quickly stop that event. And that's what a cyber team or your SOC team would typically be doing. So if you do choose the path of code, this is going to be a different team. But it's good for you to understand what's happening behind the scenes, right? So they're going to then get escalated permissions. From there, they're going to be able to get domain compromise. From domain compromise, they're going to go ahead and exfiltrate data. Here's a stat that I didn't have in here. In general, when an organization discovers that there's a bad actor rooting around in their environment, they've been caught. Statistically, that bad actor has been in that environment for up to 200 days. Why is that? Well, think about it this way. If you're a bad actor, I just told you one of the things they're going to do. If they're able to get in, instead of going and doing something right away, they're going to see who talks to who. They're going to find out what relationships they are, and if they can build a map of where data is and so on, gives them a target. They're also going to do other things. On 4B, persistent presence. Hey, first thing they're going to do when they get in is go, I better create another account in case this one gets identified and stopped. So another account's going to get created, or maybe they'll compromise a second account or a third or a fourth, so that even if one or two are captured, they still have some in. They're going to try to create backdoors, all these other things. So by the time this nefarious activity, for the data is taking place, they've been in there a long time. Okay, so I don't know how much of a surprise that is to you in general. Again, I'm going to stop here for questions. I knew this was going to be rough. Okay, I hope this is so far being useful. So let's actually talk about secure code then. When you're writing secure code, you have a responsibility. Your responsibility is to adhere to what's called zero trust principles. So when you're creating code, and or if you're in the cyber team and you're responsible for securing the environment, one of the zero trust principles, and pretty much the top zero trust principle, is called assume breach. Meaning, always assume that you've already been compromised and that nothing you have is safe, right? If you go from the mindset of somebody could already be in here, now when I'm writing my code and going, okay, have I successfully secured this? Am I using the appropriate protocols? Am I storing the data where it needs to be? Have I provided only the access that needs to be? Assume breach from all the points helps as a guiding principle to go, okay, if somebody were in here and I did this thing, would it still be protected? Right? What can I do to ensure? The second part of zero trust principle, by the way, zero trust principle, it's not a Microsoft term, right? Yes, I'm from Microsoft. I have my cybersecurity hat on. That's a term you're going to hear throughout the industry. So again, at some point when you're going, if you don't already have a job in the high-tech field, this is probably something that you're going to want to know and understand, the core pieces of zero trust principle. It's highly likely to get asked those questions. So the second one, verify explicitity. Hard to say when you have gold. What does that mean? It means verify. It means make sure that when in your code writing and you're going to allow a user to run a process or access a particular piece of data, you need to do some checking to ensure that that user is who they say they are. Does that imply that your code needs to do that? No. In order for that individual to even be accessing your application, they should have been authenticated by some trusted source. In our case, like Active Directory or Azure Active Directory or whatever your identity, Oktas of the world, whatever your identity provider might be. But you need to ensure that user is properly authenticated. So you're not doing the authentication, but you need to do that error checking, make sure that that user has been authenticated, right? And then the final part, I already alluded to. Least privileged access. You'll see in here a term that's used pretty frequently is just in time, just enough access, right? That's the concept of if users don't need access to, you're part of a project team, and you're responsible for a set of functions. If you don't have a need to access all of the other program information to do your job properly and safely, you shouldn't be given access to. Just because you're part of the team doesn't mean you should have God rights. Likewise, if you're in a domain, it would be ludicrous to assign everybody as administrator, right? That nobody does that. The idea is you want to ensure that you give only the access that is needed to secure the application and make it run properly. There's a little nuance in the wording I'm using there. I have to tell you, over the years, I have had so many applications that I've gone into a customer's environment where we evaluate it and we discover that the application functions the way it was supposed to, providing takes an input, provides the appropriate output. But when you look at what it's doing, is the only way it was able to do that is it has to go access things that average Joe user didn't have access to. The coder didn't know how to do it properly, and so what they did is they gave it elevated permissions. Great, so your program works. Problem is, if I'm a bad actor, all I got to do is access that object and go, hey, by the way, this one also has access to an entire library over here, and be able to go to that library and get everything I want. So least privilege access, super important. We just talked about identities. When you're doing code development, using the proper identity is important. I already brought up the term administrative user. I think in general, everybody on here probably has a decent understanding what that means. You have in the terms we call it God rights. Basically, you could do everything, right? Never, ever, 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 ever. Did I say ever? Ever use admin user rights to test your applications, because guess what? It'll probably work, right? Bad code can be made to work with admin privileges. No, you want to test your rights with the least privilege, because that's what your users should be getting, right? Do not test with an admin user. As a matter of fact, if I were in your organization, I wouldn't give you admin, right? Nothing personal, don't know you. But the idea is, goes back to the just in time, just enough access. In that role, you have no need for that level of access. Therefore, it's not good to have that. Okay, you're going to hear a term more and more called a managed identity. Managed identities are a set of identities. I'm going to kind of read this out. Set of identities that do not require storing passwords or secrets. By the way, what's a secret? Yes, I know I can whisper something in your ear. That's a secret, right? No, a secret means it's a token, a code, 32, 64-bit level code that is embedded that can be shared between. And a lot of times the way it's written is a double redundant key or a hash key, where I have half, you have half, and we put them together, we now have the whole thing. So my app has half, the authentication mechanism has half, and you need both. That, because those keys don't change by themselves, they become an issue. Falling on our own sword, those of you might have read that Microsoft had an issue at the government level with a bad actor getting into certain emails and so on. And when we went and looked at what the root cause, how were they able to do that? It's because certain applications were using secret keys, secrets, which, in itself were okay. The problem is the secrets weren't being refreshed. The keys weren't being rotated. That's what the term is called, rotating keys, right? So once it was out there, it kind of laid out there because, well, somebody forgot it was in there, right? So using managed identities basically takes that out. There are no secret keys. So it's a different format. So as you are coming into the coding world, start thinking of those managed identities, okay? And then a restricted user. A restricted user, you might think of it as just a standard user, right? The idea is a restricted user is one that you can use for testing, you can use for your purposes to find out what's going on. Give me just a second. Okay. So on the bottom here, never embed usernames, passwords, and code segments, right? Never embed, that's another one. Never embed test login accounts in source code. Good gosh, I can't tell you how prevalent that is. That happens all the time. Think of an application that has, 1 million lines. Somewhere in there, somebody was doing some testing and embedded a test login account. Okay, you're getting ready to wrap that up and move that over to production. Are you the one that gets assigned to look through 1 million lines of code to find that particular login, that test login? Yes, you can always do a search, but you got to know what the test login name was to go find it, right? So not fun. Don't use test logins. The bottom one, I think, is probably the key takeaway on this one. When you're developing your code, you need to develop it to be as secure as it can be unto itself. Do not create code and do loose, willy-nilly stuff thinking, they'll capture that, on the outside and put a wrapper around it. Now you're really trusting that somebody else is going to do what you probably should have done. That's a key piece. I'm not implying that you're going to do that, but that's a key mindset that you should have. Secure your own code to the best of your ability, and don't count on others. There's some things you have to do. Your code most likely is not going to be doing authentication, right? That's the directory, that's the identity management solution, your Azure Active Directory, your Oktas, and so on, that's going to do that. But you can still validate that information coming in, right? So, questions?
I do have a question.
Yes.
What security risks are for like simple web applications or code that seems to be pretty contained in a closed system? Like it doesn't use any identities or logins, doesn't contain any personal identified information. And I guess like a good example of this would be like Flappy Bird or Cookie Clicker if you're familiar with those, like
One
apps.
of them, yes.
Okay, yeah. So like what kind of security risks are there in like apps like those?
In itself, the risk is actually pretty low because, as you stated on both of those pieces, right, it's self-contained. It really doesn't go out and make calls to other applications. Where it becomes more risky is when it's used in conjunction with other applications, that it now takes on an extended role because it might not necessarily be able to accommodate those additional security principles.
Okay.
I used to work for the federal government. I'm retired military, and then I was a contractor as well. We have a thing called RedNet, which means that any of the communications of the computer systems and comm systems are totally within boundary. Nothing leaves those, so it can only talk to other RedNet systems. As you make things more and more secure and more encapsulated, the less useful it becomes, right? RedNet is great, except it can only talk to that point over there. Well, I need to be able to talk to these. Well, they're not on RedNet. So now I have to break that security boundary to go over there. So the more useful your application, basically the more convenient you make it for your end users, the more theoretical chance there is of hacking, penetration, so on. Given enough time and the compute power that we have today, any app is certainly vulnerable to some type of either a coding error, a bug, a penetration, and or even something outside of those, right? So nothing is perfectly secure. So everything I'm telling you is do your best and adhere to these principles. Even though the end result could be something, but that's where regression testing and continual testing and bug updates, right? Everybody knows Microsoft publishes updates to our software regularly, Patch Tuesdays, right? It's going to happen. Where do we get that information from? Out there in the field. Hey, Microsoft, I noticed that if I put in this particular URL in the Edge browser, and then I put a / instead of a /, I now got access to something on my system that I wasn't supposed to. It's like, oh, and we'll go and they'll do a bug report. We'll go look at that, determine how that bypassed, fix it, and we issue a patch, right? By the way, patches themselves can be dangerous. They need a lot of testing as well. And not slamming my competitors, but everybody heard recently, you might have been affected by some of the stuff that happened with a bad patch update that took down the systems throughout the world and a lot of the reservation systems and everything. It was something totally non-nefarious. It wasn't a bad actor that did it all. It was simply a piece of code that accessed an out-of-memory range out-of-bounds memory range, and the operating system said, I don't know what to do with this. I'm just going to blue screen. It can happen, right? So, okay. Thank you for your question. I hope that answered it.
Yes, it does. Thank you so much.
Thank you. And thank you for asking the question. I love being interactive with people. Okay, so let's get into the actual design principles. Microsoft and any organization that you go to work for of any salt is going to have some type of a development lifecycle model. This is me speaking directly to you, not Microsoft. This is Rich. If you go to work for an organization and do software development, they don't have a lifecycle model, you might want to rethink your choices, because that's a surefire way to have issues both in the coding and or the security side. A well-designed application will follow some type of a lifecycle model. Right? Microsoft's model is called Security Development Lifecycle, SDL, and the boxes that you see that I'm going to get into detail in each of them, these are what all these are about. So again, taking back to what would you expect? If you came to work for Microsoft and you're going to do software development, you'd be part of a team. And you're going to be part of a team specifically to build applications or extensions for very specific pieces of the environment. You're not going to have access to everything. If you're on the Outlook team, for our Outlook email, you're not going to be part of the Defender series of all our threat and analytics. You're not going to be part of the Copilot. You're not going to be part of the Edge browser, right? You're going to be doing Outlook, but they're all going to follow these same design principles. So the main ones: training, requirements, design, implementation, verification, release, and response. Like I said, this is kind of an overview. I assume while I'm talking, you probably read these. I'm not going to read the lines. I will go into the next screen and break out each of these before I do. Any generic question on this? Otherwise, okay. Let's get into the first couple. So the design part is basically the first 3 blocks. There is the training. So this is where I was pointing out, and I made the statement that to be a good code writer, developer, call it a developer, right? But to write code well requires training, not just in being able to write code, but understand how functions work and function calls and all the other things that are part of it. Understanding how a lifecycle methodology works. But I tried to provide some of the initial stuff here of learning what threats are and how attacks happen. If you're not curious, and because I already gave you, I gave you the buffet speech, right? I gave you just enough to wet your whistle, but not enough to really chew on. Hopefully you'll be curious enough to want to go out and get a better understanding about how threats work and what are the threats out there and so on. Because the better you can understand as to how threats happen, how bad actors get into the environment, how they access your code, how they're able to leverage seemingly innocuous things in code. I mean, these days they can even break into printers that have no interface to them at all. They can break into printers, be able to get into the local network and do network sniffing and be able to find other devices on the network. You just need to know all this. Pardon me. Okay. The next one, requirements. Requirements are huge. I have certainly had it before working for the federal government where they had a budget and they give us a list of things and say, I want you to go out and build this application. Here's the input, here's the output. Okay. What does it need to do? What's the stuff in the middle? Well, that's for you to figure out. It's like, what? So requirements are very, very important. When you're working on that team, if you're not given the requirements, again, be curious. You need to ask them. I gave you a couple of bullet points in here, right? Why are requirements so important? Well, you need to know what this app or this function or whatever level that you're building, what does it need to do? What are the inputs? What should it not do? What type of data does it access? What's the return value? What happens if it gets a bad call? What if the data isn't found? What are the requirements that are needed? Does it need to run on Windows? Does it need to run on Windows 10 and 11? How about some of our legacy Windows 7, 8? Does it need to run on Mac? Does it need to run on iOS? Does it need to run on both? I can go on for an hour just on different pieces of requirement. That is huge. Until you really know what the requirements are, you should not move to the design phase. My personal philosophy that I've used for eons, because it's the way my brain works, is I'm a fan of whiteboarding. I always use, if you can't draw it, you don't understand it. I'll give you an example. I've had so many times as a consultant where I get into an organization and I'm going to help them redo a process or redo a deployment. And I said, okay, tell me how your process works today so that we know what we're fixing. Oh, well, we do this, and then it goes into this application, and then over here it does this, and then we do this. It's like, okay. And then I'll take what they just told me. I'll draw it on the whiteboard, and I'll draw an arrow because it comes into here. And then from here it goes over to here, and then from over here, and somebody in the back will go, no, that's not quite correct. It doesn't really go into that box. It goes into this other box first. Oh, where's that box? Oh, okay, it's a piece of hardware, software. Got it. Okay, it's a load balance device. Okay, from there, and then it goes directly from there. Well, no, it gets transformed. It's like, oh, and how does it get its information? Well, there's an input file. If you didn't draw that out, or if I had not drawn that out, people would go, oh, I know, magic in, magic out. Oh, I just know it goes into this box and comes out this way. But it actually didn't. So gather your requirements. Once you've got the requirements, then the design phase. Now that you know what the parameters are that you need to build, you have the design part of, you have what it needs to be able to do, what the input, outputs, and so on. Now, when you look at the design phase, you're looking at things like when does this need to be created? What is it supporting? What interaction am I going to have with other teams? Right? Design is that level. Questions on that? That's a pretty important step right there. Okay, go ahead and think about it. So now this the next two boxes are infrastructure and validation, right? The name is verification, but it's validation, right? Implementation is the generic term we use to say, all right, now that you've created this app, how will you deploy it? How does it get out there? If you worked for Apple and you develop an app, if you develop an app, it's going to go in the Apple Store. Microsoft has a Windows for Business store, right? Maybe you're going to publish it to Google, or how will this app get ultimately to the end users on their device? Because that needs to be taken into account in how to, what requirements are there for the infrastructure. Now you're going to be working with the infrastructure team. Hey, in order for my app to work, I need this, this, and this. I need this connectivity. It has to make this call to a database. It's a SQL database. Here's its URL. I'm going to be using this transport protocol. All of these things need to be taken into account as part of the deployment, the implementation phase, right? And then there's a verification phase. So understand that I alluded to it earlier. Any code that's written is not going to be perfect the first time it comes out, period. Nobody's code goes out perfect the first time. They never be perfect, right? It should be threat resistant, but believe me, you're not going to ever hear me say, oh, you can't break into our code, because that's the first thing people are going to go, oh, yeah, let's try that. So the idea is you need a verification phase. You need to be able to get it published, publish it to a subset of individuals, have them do testing. Maybe you've heard of certain testing phases like UAT, user acceptance testing. Typically, a UAT phase is where you're getting feedback from your end users on the interface, right? Hey, how sexy is my interface? I'm asking these 3 questions for input. Are there other inputs that should have been? Oh, you don't like the color that I chose for the prompts because it washes out. It's hard to read on a mobile device, right? So user acceptance testing is a critical piece of verification, right? That's just one example. Hey, it's supposed to provide an output in this format. Did it give you the output in that format? Did you need it in another format? Right? So it's an iterative process. Microsoft, our process, we deploy in a pre-release. You can think of it almost like a beta. So we do a pre-release, then we do a private preview, and then a public preview. Pre-release is a defined set of internal users to go test it. I'm going to pause right here. So many times when I work with customers and we're going to do that beta testing, right? One of the things I used to do is I would go to the help desk and say, hey, we're about to start testing an application. Who are the users that call you the most and complain about something that's not working in their system? Who are those people that are really a thorn in your side? Believe it or not, that's who you want to test your app. If anybody's going to find something and give you feedback that it doesn't work, it's them. So kind of wacky to think about, but they're probably your best testers. So, okay. The release phase. So I just alluded that Microsoft has those multiple phases. So you've got the pre-release internal, then you've got what's called a private preview. That's where we actually do give it to customers. They are select customers. There's a whole legal thing that gets filled out that basically says we're providing this code to you. If you use it in your production environment, know that it could be not perfect. You're willing to assume certain risks here. In agreement for these risks, if there's any type of issues, we will have a dedicated team to work with you on resolving those, and so on and so forth. And it's a very small subset, but those are ones that we want to be able to. And they're going to have different demographics, right? Different sizes, different types of environments, financials, marketing, manufacturing, whatever. Okay. And then the response phase. So the response phase is part of that iterative. Everything's iterative, right? So this is where you're actually going, okay, during the life cycle, once it's out there, as I said, Microsoft does it. All the major vendors do it. You have patches and so on, right? You can't just throw it out the door and say, ha, it's good. I guarantee there's going to be a 1.10 and a 1.2 and a 1.3 and a 2.0 and a 3.0 and a 3.1, right? Your app is going, assuming that it has value out there, it's going to continue to evolve. Pardon me. So there has to be a post response level to it. So that needs to be taken into account. Is that your responsibility? No, but it's part of the life cycle, that you're going to be part of that. Let's see, how's my time? I think I'm still okay for now, right? I got about 30 minutes.
That's correct. A little less than, yeah.
Okay, give me just a second. Sorry about this cold. Okay, some tips. I pointed out a couple of these already, right? Don't hard code login credentials, use managed identities. They randomize your session IDs. Again, think of secrets and tokens and do token refresh or rotation keys. Don't trust user input. I've said it twice already. Now I'm going to say it a third time. Your app most likely would not be doing the authentication. You are probably doing the authorization. That's the difference between the two. Authentication is the app that basically proves the user is who they say they are. That's usually the combination of username, password, or some format like that, right? Your app, when you go to allow a user to use it, is what should they be able to do? Now that I know they are who they say they are and they go to access my app, what should they be able to do? These days, most applications have multiple levels of access in them. You know, you might, if you're a super user, maybe you can do all these things and get to a submenu. If you're a certified user, maybe you can run an elevated permission, elevated level and have certain access. And if you're just a worker, you know, a worker level, whatever you call it in your code, you know, they can only access it, you know, at this level. So you're going to be doing the authorization, not the authentication. Okay, so verify that the user has been verified. Validate data. Yes, that is your responsibility. If you're making a call to a database or a SQL server or wherever you're getting the data from, I'm willing to say, unless you're writing apps like a game app or something that's totally enclosed, chances are your app needs to get data from someplace to be useful. On the high order of the 90s, you know, 92, 94% of all the apps that serve a useful function, it's taking data from different places, pulling it in and doing something with it. Okay, so let's see.
Hey,
This
Rich.
one's less. Yes,
There's a couple
No,
questions
no.
here.
Oh yeah, there's a question in the chat.
please.
No, you go first, Jerome.
No, that's what I was gonna.
Oh. How do you prevent prompt injection for AI? That's question one. Question two is, how do you manage keeping API keys private for the purpose of this app?
Okay, I'll answer them in reverse. The APIs are somewhat of a challenge because you have public APIs and private APIs, right? We have that as Microsoft. We have that with certain partners. You know, for instance, there's some things we can do with Google Apps that we can do because Google has a public API for it. There's some things we can't do with it because in order to access that particular resource, it requires an API. They don't publish it to us. It's only internally published. So only part of their trusted ecosystem can. So APIs themselves are not a single thing. They're a multi-level thing, right? The other part with APIs is also that least privilege, right? APIs simply say we're going to publish an API is a set of environments that say here's all the different inputs we can accept. Here's what an output would look like, the format, the length, all these other pieces, you know. So it is possible to inject data into there that shouldn't be. That's where, again, goes back to that error checking and the validation comes in. Super important, right? The other part relating to AI, I am going to talk about AI a little bit after this, but I'll just briefly touch on it here. AI, and in this case, I'm referring to AI. I'm reading between the lines that you're talking about the latest generation. It's called generative AI. Generative AI is you know, basically AI that uses large language models and that is trainable and learns. At this point in human history, AI is a toddler. It's a toddler because, like any newborn, it's soaking up information at a rapid rate. It might not know what to do with that. That's where the training, just like a toddler, you know, you got to train them. Hey, this is a good thing. This is a bad thing. If you train that toddler to do the same wrong thing over and over, to them, that means that's the appropriate response. AI is no different. So in Microsoft, we have responsible AI. We have a whole predefined set of rules that we will adhere to, and that any of the AI that our coders create or access has to meet these requirements. And one of them is data validation. There's also a phase, and it has a name, it's eluding me now, where you also have to look at the prompts. Prompt is usually how you interact with AI. You have to look at the prompts, and before that prompt is passed to the AI compute, is do pre-validation to go, is this something that should be allowed, right? Is this type of question either valid, or is it asking it to do something that breaks the boundaries of what our particular version of AI is supposed to do to keep it from learning the bad thing? All organizations have or should have that. I have a certain competitor that their generative AI had a little bit of a problem determining the difference between certain classes of humans, right? I'm not going to go into depth on that, but you probably read it in the paper where somebody did a query and asked their AI to generate a picture of a particular type of person. It generated the whole wrong type of person. Well, why did it do that? It's because of what it was taught. I do not know how it was taught or why it was taught that way, but it didn't learn it on its own. It got it from that, so there was not that boundary, the guardrails is a word here. Those guardrails were put in place. We can speak hours and hours on this one. Super important. I treat AI as the Spider-Man theory. With great power comes great responsibility. Pardon me. Okay, let me finish this out. I hope that answered your question. We will have another opportunity.
Yes, he said yes.
Perfect. Thank you. Okay. Again, I've never been one to just read all these out. By now, you should have already read all of these. So let's go on to the next one. So this is a time where, again, I'd ask somebody or somebody's go ahead and answer. So I talked about this, and I talked about validation and authorization and authentication. Why didn't I mention multi-factor authentication? Ooh, stumped you. Okay, I'll try it a different way. How many of you think that multi-factor authentication is a way to protect your credentials, your identities?
Me.
Okay, there's one. Thank you for being brave and speaking up. Anybody else? You can raise your hand. You don't have to answer, but
Also
okay.
biometrics.
True. Biometric could be considered a second factor, multi-factor. So biometric could be on our devices, for instance. I tell this to a lot of my state and local government customers. I have a password for my Microsoft account. I do not know what it is. Sorry if I'm looking down. I keep forgetting I can't right here. I have a password. I don't know what it is. I have it vaulted so that if I ever did need to get to it, I can go get it. But the idea is we use all passwordless. I use biometrics. I use my face through Windows Hello, and then when I log in, my laptop's looking at my face with two cameras. One's a high def camera. The other one's an infrared camera. Make sure I can't hold up a picture of me. So it's got to make sure it's a real human. Okay, so here's the answer. Multi-factor authentication is post-authentication. You will not be triggered. You will not be triggered to provide secondary authentication until you pass the first, which is providing your username and password. So it doesn't protect your identities. What it does is it protects the bad guy, or protects you from the bad guy being able to do something with your identity. Because if they don't have your username password combination, they're not going to get challenged MFA. Does that make sense? So it's not a trick question, but it's an important nuance. You will never get MFA authenticated or prompted until the first part. So by that time, in order for that the bad guy to have done that, you've already been compromised. You're just preventing them from getting further. Yes, what was that?
I have a question.
Yeah.
So at one point, an old Gmail account of mine was compromised. Somewhere along the line, somebody used my username and put a period in between two of the letters, and all of a sudden they were using my account. Now, and then I added, then I started getting all their mail because Google then sent, oh, if that's them, it's too close to be different, so we're going to send it to her. And then, and I was still having a lot of trouble with that account until I did something. I required, in order for a new device to log on, that I authorized that device. Is
Yeah.
that post authorization or a
Um,
part of?
It kind of is. It's used in conjunction. In our terms, you'll call that conditional access. Conditional access means that at the network layer, so basically not you with code writing, but when we allow somebody to pass a prompt to an application, for instance, if I create a conditional access policy that says I will accept users that have been logged on and validated, they have to have MFA, validated MFA, so that you get an MFA token. That's what the thing that's passed is. They have to be on a workstation that's been authorized or is a member of my domain, and I can further make it even more granular. They cannot be from an IP address outside the bounds of this network, or outside the United States. Things like that. You can create these different policies in there. So it's really a conditional access policy. You heard earlier that things like biometrics that I just described, that's a form of multi-factor authentication. All of these used in conjunction are very beneficial. Typically,
It stopped my account from being hacked, so I just thought it was really kind of cool. Yeah.
I'm going to throw a truth bomb out to you. I'm talking about each of you individually, nothing to do with code writing. If you did everything perfect and never clicked on something you're not supposed to, you always keep your system patched and everything else, there's still no guarantee that you can't get compromised. Why? Because you live in the world and you're using, so for instance, my social security number is compromised, has been for many years, because I'm retired military. Did I do something wrong to make that happen? I did not. The bad actors decided, it's been at least 10 years, probably 12, 14 years now. The bad actors decided I can either go after all these individuals and try to get their username and password and do bad stuff, or why don't I just go to the one place that has all of their user information? They went and hacked the Department of Defense database. Yep. Manpower. They hacked the Manpower database. They got 2.2 million records. Mine's one of them. So they already have all my stuff. Did I ever do anything wrong? No. So even if you did everything perfect, your identity could still be compromised. I mean, look at these machines at like Targets and so on. The bad actors went in, compromised the database at Targets. Anybody who's ever swiped a credit card in Target, they got your information. It's just the way the world works now, okay? Sorry for the truth bomb, but that's the way it really is. So don't trust anything.
Yeah, we have one other comment.
Yes.
Jeramu had accidentally given somebody some code, and that resulted in a hack. And he was thankful because biometrics and device security allowed him to regain access in an hour. And
Okay.
he states, "I like this because I've been in a situation like that. It was the scariest moment of his life."
Yeah.
And I had something like that happen where somebody sent me a code and asked me to share it with them, and I didn't quite understand why. And then I realized what was going on was they were using my username and password, and of course, the code came to me, not to them. And I had to go in and quickly lock everything down. So because I misunderstood what they were asking me. So always be careful, but understand, like Rich says, your data is everywhere, so there's only so much you can do.
Yeah, let's use an example that hits home, which sounds very similar and could very well be the underlying of what he or she was referring to. How many of you buy or sell stuff on like Facebook Marketplace or Craigslist, right?
Yeah.
Okay, great. So you'll post something. Somebody will respond back, "Hey, I'm interested in this. I'd really like to come take a look at it." It's like, "Oh, great. What do you want to know?" "Oh, how old is?" Some random questions. Like, "Oh, okay, great." And then they go, "I want to verify you're a real person.
Yeah.
I'm going to send you a code."
Exactly.
Right?
What happened. Yeah.
Don't do that.
Don't do that. I agree.
Don't do that.
Yeah.
Never. Don't give them your phone number, your mobile number. You could give them a home phone number, but not a cellular number, because they can't text to a home number, right?
Yep.
I literally have a landline. If I ever wanted to, I could give them my landline number and they can't do a darn thing to me, right? Don't do that. There are so many hacks out there, but it shouldn't take you all that long to figure out. I can figure out if it's a real buyer or a scam within about 4 minutes. It's like it's all you got to know is the right questions to ask. More than happy to respond to somebody later if you want to know what those are. Okay, back to the code because I'm going to run out of time. How much time do we have?
About 15 minutes.
Okay, probably won't get through the last piece where I was going to do a quick demonstration, but it's okay. For those of you who are not familiar, you hear these terms, right? Low code, no code, and then generative AI. This kind of breaks it out. And remember, you will get these slides, so don't have to write it all down. But what's the true difference between them? Low code is where you're using some type of tool, usually the drag and drop type interface where you can get these pieces of code and functions and be able to pull them together and make an application. But with low code, you have the ability to go in and format it and make changes and add your own stuff. No code, you have less capability for that. It is pretty much, I want this piece, it's a McDonald's menu. I want this, go. And it compiles them together. That's what you get, right? So low code or no code it's all drag and drop. There are uses for them. I'm not a coder, so please don't ask me specific examples. I can't do it because I don't write code. I have my original degree back when I got my degree was in computer sciences, so I had to write Fortran, COBOL, BASIC, C++, all those. Probably don't know any of them anymore now. But the idea is, although I don't write code and I don't use them, I will tell you it was very beneficial to me because now when I'm working on scripts or doing any of the customizations for any of the generative AI tools to go do queries, we call it hunting, I have a good understanding of how those things interoperate, what a function is, and how a function call is made, and all that because of my degree. So that's right. What is generative AI? Again, I could spend hours just on that. Generative AI is the term. These days, it got morphed into just AI, but AI has been around for quite a while. We've been using it for many, many years in Microsoft for things like behavioral analytics and threat analytics and threat intelligence. That's all AI. The AI these days, when somebody says, oh, we have a new AI tool, what they're probably talking about is called generative AI. Generative AI implies that is a large language model. Basically, it has a large data set behind it that is trained to understand and associate different things together. This is a dog. This is a cat. Here's how they interoperate. Dogs can have puppies. Cats can't have puppies, right? It trains these things. But then it also takes the next step. It can learn. No, we don't want to create terminators. So, you got to put, again, you'll hear the term guardrails. You got to put guardrails around it. What is it allowed to do, right? Because they can learn a lot faster than we can. But we also talked about it, right? It's only as smart as the data it gets in and the data that it's trained on. So you can have bad injection in there. That is what some of the bad actors try to do these days, right? Try to purposely corrupt your generative AI and get it to respond in a way that it should not respond. Nobody's generative AI is perfect, period. Ours isn't, our competitors are not, because it's much too big a problem. We have specific disciplines in place to try to make it respond as appropriately as it can, but it's still working. It's a toddler. If at most it's becoming an infant, right? So, okay, and then I've already mentioned, full sales hat on Microsoft. Our generative AI is called Copilot. So when you hear Microsoft Copilot, that is the family name for all of our generative tools. So there's a Copilot for Office. There's a Copilot for security and so on. I'll give you a quick example of what Copilot for Microsoft 365 for like Office is. I can go and say, you know what, I had a number of meetings over the last month or 2 or 3 months, and I remember having a discussion with Billy Jones at Department of Public Services. I can go to a Copilot prompt to go, how many meetings was I in that involved Billy Jones, where the topic was a water treatment plant? And it will go out and gather the data from the places that I have access to, so it's working on my behalf, not of its own, on my behalf, meaning if I don't have access to a particular set of data, it doesn't. And we'll go pull that back. Make it very easy. Some of you maybe have used some form, ChatGPT or whoever you're using, to create data, right? Hey, write a resume for me in this format and give it a professional look and all this stuff, right? So all these things, we call it a Copilot because it's working on your behalf. Okay. Let's get a couple more so I don't run out of time. Securing source code. A couple of things. Remember, we were talking about that whole lifecycle process of the steps to building the code, but while you're working on it, y'all are aware that you don't write code and publish it and everything happens in a day. It doesn't work that way, right? You're checking in and checking out your data. It's pretty darn important to know where that data is. Where is it being stored? Who has access to it? Who provides that access? Is it something that you have ownership of that folder or that folder structure on a server somewhere that it's being stored? Are you determining who has access to it? Is that being done at the IT level, right? So you need to look at appropriate protections for the code itself. You have to implement what's called access controls. Basically, not only who has access, but wouldn't you want to know when it's been accessed? What if all of a sudden your code starts acting really wonky and you're going like, but I just ran this 3 days ago and I didn't have this issue. And if you had access controls and you go in the logs, it's like, well, wait, Sue went in and edited this thing on Friday. Hey, Sue, what did you do to the code? Oh, you added this new module? We got some error checking going on then. Okay, right? So you wanna be able to secure your code, but also look at the whole authorization, authentication, and logs and so on, right? And of course, things like security tools. Hey, I also want to know maybe Sue wasn't the one that went in there. Could be somebody outside the bounds of our network. So it happens. Give you a little flair for what Microsoft does. So we have, just like Copilot is the name of all our generative AI tools, Defender is the name of all our threat and analytics tools. So all the things that provide threat protection, threat discovery, automatic remediation, things of that nature. We have a specific tool just for DevOps. We gave it a really unique name, Defender for DevOps, right? Just so you have a flair for what you could expect out in the wild when you get to work for a larger company. We understand all the security that I've been talking about for the last hour plus, and we know that it's a lot to do. So we make tools then that if an organization deploys these tools, it will help with protecting that data, determining who has access, determining where there's access violations or potential, right? Could be access from a location or a user that we've never seen before. It doesn't mean it's nefarious. Maybe you gave somebody on purpose permissions and we've just never seen them, right? So we're going to pick those up as a vulnerability. But we also take it to the next level and say, hey, because, well, I think we know a thing or two about writing code, why can't we also use our tools to help you help yourself? So another thing that the tools can do is look at vulnerabilities and expose secrets and various other things. So when you look at the checklist of some of the things that the tool can do, again, I'm not selling anything to you, right? You're not my target demographic. You're the organization you could work for would be. But I'm giving you a flair for some of the things that you will most likely run across in the code world. Tools to help you. So when you're thinking of tools, don't just think of tools to help you write the code, but tools to help you secure the code and protect it from unauthorized access and publish it and even wrap it up, right? so that it can be transportable and things of that nature. Yes, you'll notice down at the bottom, the last one, perform code scanning for vulnerabilities and misconfigurations. We know if you're making a really crappy function call, right? Hey, maybe there's a better way. You got 42 lines making a function call that could do it in 3. We're going to pull those things out, because if it's got 42 lines and you only need 3 to actually make that call, that's what, 38 lines or so that give more of an attack surface for something to go wrong. So it's in your best interest and ours to help you be efficient with that code. And of course, it makes it smaller as well. Questions on the screen? And I kind of already talked about, our generative AI. I believe I'm at time. Is that correct, Thelma?
Nope, you got 10 more minutes.
Oh, I
Or
do?
not, nine more minutes.
Yes. Okay. Let's talk about it really quick then. So one of our Copilot tools you would interact with if you were on a SOC analyst. So basically not the end user. So this particular one is not the one to help you write resumes and create. I mean, if you've ever used it for like developing a PowerPoint presentation, what might have taken me 3 hours to develop, I can do in about 4 minutes now. Just feed it input and say, create PowerPoint presentation from this data with this type, and I want pictures that represent users in the education space. Wow, is it perfect? No, I'm still going to go do some stuff with it, but man, it's going to save you a lot of time. Copilot for security is designed for the SOC analysts to be able to do things like being able to identify, look at things that are going on in the environment, be able to do hunting queries against them, be able to determine what is happening in those environments, and be able to determine an appropriate response and or trigger a response for those, right? It is not designed to replace the human. It's designed to augment the human. Quite frankly, the perfect use case at this point in time, again, it's like all generative tools, it continues to grow and capabilities get better. Right now, the perfect use case is for an organization that has a SOC analyst team that maybe they're analysts, maybe it's a combination of newer analysts and seasoned analysts, or maybe they're mid-tier analysts where they're not typically doing things like hunting to go find stuff. They're looking at, triaging the alerts and everything that are being discovered, but they don't really go out and actively discover. It's designed to help them be more efficient, to be able to perform tasks or get tasks done that maybe they didn't know how to do before, that they can get augmented. That co-pilot, the co-pilot on your shoulder. Hey, do this thing for me. Again, when I speak of things like generative AI and Copilot, I'm giving it to you in the lens of how Microsoft implements. I don't work for Google. I don't work for the other organizations that have their own, so I can't tell you specifically under the covers what they're doing. But I can tell you that we have an entire trust model that exactly here's how all these work. Your data never leaves your environment. In the Microsoft world, our cloud is called Azure. You have a tenant, you have a space. If you're an organization, you have a space in that cloud. Your data resides in that space and it's protected. Your security Copilot and Copilot in general has access to the data in there. It does not have access to data outside of there unless you specifically grant it. It also cannot get data from there and pull it in unless you give it access, and it cannot share your data. It cannot use data from somewhere else to train itself. It can use your data to train itself based off of a large language model, but it all remains within yours, so it's not used to train anybody else's. And then I also alluded that another core piece is if I ask it to do something, again, looking at prompts, if I ask it, hey, go do this thing, go tell me about this incident and tell me about the users that were affected. It's basically going out and gathering the information that I would have had access to at some point, but it's much faster, much more concise. But it can only bring back the data that I would have had permissions to. It can't. I can't in my role. I can't say, go write a report and tell me what the top 10 pay structures are for the executives at Microsoft and how many shares each has. If that's publicly available data, I suppose it could produce that, but I'm pretty sure a lot of that isn't, right? So it's not going to bring that back for me. It's kind of important. That's the way we work, right?
I have a question.
Yes.
Is the Copilot then a part of if I do Microsoft 365?
So there is a Copilot for 365.
So because you were describing having it build a PowerPoint, and that's something I would do. So I'm trying to find out if that's something.
Yeah, that so Copilot. It's called Copilot. Copilot for M365. It all
Okay.
depends on the licensing that you have. I'm guessing as an average user, you most likely don't yet have that, but you might. I'm not on that side. So look at PowerPoint and Copilot and see what licensing that you have available. You could do a quick query.
I'll take a look online. I just was curious
Okay.
because I have an older version of the Office suite, so I probably should get something a little newer. So.
All right. Let me just cover this slide really quickly, and then again I'll open it up for any final questions on this. So again, we have multiple Copilots. Copilot's just a family name, right? It's not a. I always tell my customers, it's not a thing. It's a family of things, right? So when you look at the Microsoft 365 Defender, basically our security portal for a cyber event, it's a little hard to see on the screen here probably, but if this was full screen, you'd see on the picture on the left pane, these are all alerts that our generative AI automatically put together and said, hey, these particular activities are either a known threat, they are an indicator of compromise, basically a bad actor did something that we just know a normal user would not do, or it could just be an alert. Hey, we've noticed something here that a user just did. They set a forwarding rule on their mailbox, and they've never done that before, right? Does that mean it is for sure a threat? No, but it's something unusual for that user. So all those alerts are joined together from all the different tools that the organization's using, and then we build that picture in the middle is a timeline. So if you were on the SOC analyst side, so this is, like I said, you might be interested in this type of stuff. So now, if you're a SOC analyst, your number one priority is to make sure whatever bad thing, if it's an actual bad thing, that it's stopped right away, and then understanding what took place and what was affected. We call it a blast radius. How big was this thing, right? But you also need to know, how did it get started? Whose patient zero? Did somebody click on something they weren't supposed to? What workstations were affected? What data was accessed? What data was requested? All this type of stuff. So all that's built out, each of these link to each other. So I can select one of these. It'll show me, hey, this user on this workstation clicked on this, which then created a file which attempted to go to here. That file then tried to automatically upload to a URL at IP address 12345 outside the bounds of the network, and hopefully our tools caught and stopped it. But it's going to show you all the things that were taking place. And then on the far right, this is where the plugin, we call it an embedded experience. So basically, Copilot for Security, or Security Copilot, just put it back. Security Copilot will basically be able to break all that out in human language, say, here's what the event was. Joe Smith received an email, clicked on a URL in there. That URL went to IP address 12345. This is a known through our threat intelligence database. This is a known credential harvesting site, and access was blocked. And then this thing happened. This thing happened. Right? You as a SOC analyst, you can dig through all this and find all that information. Copilot just pulled all that out into a format that is human readable in minutes. That's the value of the generative AIs when you look at it from here. In the code writing world, I assume you're already using some type of, chat GPTs or OpenAI or whatever format you might be using. You're probably using some to help you generate some code, right? Ours can do the same, and ours does it in reverse. If a payload was delivered on a workstation, you can ask it what would this payload do, and it can decompile it. Maybe you're not a code writer in whatever language, Python or JavaScript, right? it can decompile it and say, this would make a call to so-and-so, set permissions for X, upload file with this file name and so on. Maybe you don't even have that capability. Maybe it's not a language you know, right? So these are the benefits that you'll see coming out more. And again, you understand I'm from Microsoft, so I'm telling you what Microsoft is doing and how we're rolling through. I think we are just about at time. Any last questions? And then Thelma, where do we go from here? So any last questions?
That's where we go first, is the last question. Zane is concerned about privacy with AI, so I can run it on my local hardware.
Okay. Again, AI is.
I'm sorry, I said I'm too concerned about privacy with AI to run it on my local hardware. There we go.
Yeah, no, a valid concern as well, and quite frankly, I assume he should be, right?
Yeah, no, he said it was a comment, not a. He said it was a comment, not a question, but I think you can comment on his comment. Go ahead. Sorry.
Yeah, he's not wrong, right? I said that it's a toddler. I'm not gonna hand a knife to a toddler and tell him to go run, right? So yes, you should be concerned, but you shouldn't be analysis paralysis. You shouldn't be so concerned that you're just not even going to use it. You have to understand what you're asking it to do, and you have to have and you have to have some common sense. If you ask it a question, and I say it because remember, everybody's generative AI is a little different. They're each trained different. I can't be specific about somebody else. I can tell you how ours works to a certain level. It's going to give you data back. But one of the pieces I had in one of my files, I basically said, you're the human. If you get a result back from AI, you're responsible for validating that it's true, right?
Correct.
So that doesn't change. I don't care whose AI it is. If you ask it a question, you get back an answer that sounds questionable. First thing I would do is ask it in a different way and see if you get back something similar or whether you get what you actually expect. It's all these days because it's taking together the input you give it, who's ever generative AI that is. It's taking the input you give it and weaving them together and trying to find the rationale between them. Remember the dog, here's a dog, here's a cat. What's the difference between a dog and a cat? Here's a puppy, here's a kitten. Cats can't have puppies, right? So it's weaving the information together, then rationalizing against that query and giving a response. Sometimes changing the order of the query might give you a different response. So it's very normal. And quite frankly, I'd be willing to bet you if you write a query and every day for the next week you put that query out, I bet you would not get the same answer every time. Because it's constantly learning and or it could even, after the third time, it might even think that by asking it so many times, it realizes that, so I must not be giving you the right answer because you keep asking it, so I'm going to give you something different. It could happen. Don't throw the baby out with the bathwater.
So he says changing order of query is due to like overfitting and random seeds, right? I don't know what that means.
I missed the first part. What was it? Due to what?
Changing order of the query is due to like overfitting and random seeds. I don't understand that at all, so I'm not sure I'm reading it right.
So those pieces could be part of it because everybody they do prompt manipulation differently in everybody's generative AI, right? Because remember I said, one of the things that we do is when you submit a prompt, the first thing we do is we send it over to a particular logistics logic that basically says, okay, is this a valid question? Or are they trying to ask it to do something that is outside the bounds of this? That it should be asking. It could very well just come back and say, I can't give you that kind of answer, or this type of prompt is not acceptable. It doesn't meet this policy, right? So the idea is there has to be some pre-processing in there. Everybody does it a little different. So changing the order sometimes just also stimulates AI to go look at the data differently. I mean, if I told it, order these three things, and I change the order of them, I might get a different, because A plus B equals C doesn't imply C equals A, right? It's math. It's the way it works. So I hope
Well,
everybody realizes, and I know we're at time, I hope everybody realizes that AI at this point didn't write itself, right? We're not that point yet. Someday we'll probably get there, and I hope we don't, but it didn't write it, we did. So our flaws and the way we train it are the biggest concern, right? Again, I threw out a statement there where when you tell it to draw a particular type of human and it comes back with something totally wrong, why did it do that? Because somebody told it totally wrong. Well, it was the weak link, us, humans. So, okay, Velma, I give it back to you. I hope this was a useful presentation. I covered the core pieces of secure code, but I really wanted you to understand the bigger picture of you need to understand the environment around it to really write secure code.
Well, thank you so much, Rich, for coming. I always like when you start with what the environment's like, because it changes every year and things modify. A lot of the stuff is still the same every year because people are still doing the same thing because they're making billions of dollars. So they're not going to change as long as it works. But I do like you when you come with that and then you put it in the context. And then when you start talking about how to defend your own code, it puts it in a clear context for me. And I hope it does for the rest of the people who are visiting as well. So our guests. But thank you so much for being here. So if you would be so kind to stop sharing your screen. And I can take over, and you're welcome to go back and nurse your cold. And thank you again for, I guess I should turn my picture on. Hang on a second. Thank you again for coming today. And sorry that things got a little convoluted there at the beginning, but you made it, and we're glad to have you.
It was all me, and again, I apologize to the team for being a couple minutes late. It was totally me. I'll do this. I'll hang around. I'm just going to